Okay, from section 2.4, which was on the chain rule, we have questions 13 and 31. So 13 says y equal to the cube root of the quantity of 6x squared plus 1. Let's rewrite this in a little bit different way. We will rewrite this as 6x squared plus 1 to a rational power of 1/3. Right? Same thing as saying the to the third root. Okay, so chain rule says that we can take an inner function and treat that inner function as a single variable and act like we are taking the derivative of this entire expression where 6x squared plus 1 is one variable and the variable that we're taking the derivative with respect to. So treating this as just one whole block, one whole quantity, so even I'll box it all in red, right? So saying that this thing in boxed red is one single variable and you're taking the derivative with respect to this variable. For instance, if I called this u, if I wanted to find the derivative with respect to x, first I find the derivative with respect to this thing, which you would do by just using the regular power rule. You'd bring down the 1/3. You'd leave this as it is, 6x squared plus 1, because that would be the variable. And then you decrement this 1/3 power by 1. So that's 1/3 minus 3/3, which would be negative 2/3. Okay, but you can't stop there, unfortunately, because the chain rule says that once you take the derivative with respect to this as the variable, then you have to find what the derivative of this is with respect to x. So you need to multiply by the derivative of this with respect to x. So the derivative of this is, well, the derivative of these two terms added together. The derivative of 6x squared with respect to x is, again, power rule. You bring down the 2, multiply it to the 6, so that becomes 12x plus 0. So that's just 12x. So let's look at all the factors that we have right here. We have a 12x, so we can maybe bring that. We have the 12 here and the 3 here. That leaves a 4. So this is equal to 4x over, and we can send this quantity right here down into the denominator because it's raised to a negative power. So this becomes 6x squared plus 1 to a 2/3 power. And I believe that's what we'll find for the answer in the back of the book. So on to the next one, problem number 31. Again, we treat this quantity that's being raised to a 3rd power as an inner function. So we first take the derivative as if this whole thing was the variable that we were taking the derivative with respect to. So we say that this is equal to 3 times, bring this whole thing down, 1 minus 2v over 1 plus v, and decrement the 3 by 1, which is 2, so that's the power rule, general power rule. And then we multiply by the derivative of this with respect to v. So to find that out, that is just the derivative rule, right? So I'm going to bring it down here because I'm going to run out of space, unfortunately. Oh, excuse me, the quotient rule is what I meant. So the derivative of f with respect to v is going to be 3 times this raised to a 2nd power times the derivative of this with respect to v, which by the quotient rule is down d up minus up d down, divided by down squared. So I'll put the divided by down squared right here. Give myself a lot of room here. 1 plus v quantity squared. And then up top here I have down, which is 1 plus v, d up, and then d up is going to be 1, the derivative of 1 is 0, derivative of negative 2v is negative 2, so this is just negative 2, plus up, which is 1 minus 2v, times d down, and derivative of 1 is 0, derivative of v is 1, so this is just going to be multiplied by 1. Okay, so this is as if this is all on one line here, right? So maybe I'll come a little bit more to the left here. Simplify this out a little bit. We won't do a whole lot of operations here. We'll just 1 minus 2v over 1 plus v. Just bringing this part down. Multiply that too. This negative 2 carries or distributes to both terms here, so we have negative 2 minus 2v. Now here we have plus 1 minus 2v. Oh, this should be a minus here, shouldn't it? Yep. Minus, so that will make this, let's see, okay, minus 1 plus 2v, minus 1 plus 2v, divided by 1 plus v squared. Okay, so I see that I have a minus 2v and a plus 2v. They cancel additively. So I have then minus 2 and minus 1, which is minus 3. So I have 3. Maybe I want to distribute this 2 to the numerator and the denominator right here in this factor, because I see that I have something that's very similar over here too. So this gives me 1 minus 2v squared times, this came out to be negative 3. And this is all divided by, here I have 1 plus v squared, then there's from here this 1 plus v squared, they're being multiplied together, common base, so I'd add their exponents, so this gives me negative 9 times 1 minus 2v quantity squared over 1 plus v quantity to a 4th power. And that should be the answer to 13 and 31. So in the next video we will continue on with more problems from this section.